Hello boys and girls, welcome to chapter 9 where we're going to be looking at area. We're going to do a quick overview of 3 lessons. Lesson 1 on page 661 is area of parallelograms. Lesson 2 found on page 673, area of triangles. And lesson 3 found on page 685, area of trapezoids. We're going to go through these lessons quite quickly due to the limited amount of time that we have. Let's get started. Starting on page 661, as I mentioned, we're going to look at lesson 1, area of parallelograms. And let's get familiar with the vocabulary. Okay, a polygon. That's what we're going to be looking at. A polygon is a closed figure formed by 3 or more straight lines. A parallelogram is a quadrilateral, so it has 4 sides, quad, with opposite sides parallel and opposite sides the same length. A rhombus is a parallelogram with 4 equal sides. Fill in the lines in the diagram with polygon, parallelogram, or rhombus and draw an example of each. As mentioned, we have to speed up a little bit, so I'm going right to the answers, but I will talk about it as you draw it. So we have a polygon. A polygon can be a parallelogram, it can be a rhombus. A polygon encompasses everything. Okay, because a polygon, as we mentioned, is a closed figure formed by 3 or more straight lines. So here is a closed figure. This is a closed figure, and this is a closed figure. And they all meet the same standard. They all have at least 3 straight lines. So, by 3 or more, yes, straight lines. So all of them, a parallelogram can be a polygon. But then a parallelogram cannot be a polygon. Okay, a parallelogram and a rhombus are similar. A parallelogram, we mentioned, is a quadrilateral, right? 4 sides with opposite sides parallel and opposite sides the same length. So opposite sides parallel and opposite sides the same length. So there's our parallelogram. And a rhombus is a parallelogram, as you see it up here, with the exception that all 4 sides are equal. It's like a square that got pushed a little bit on the side and it's tipping over. You see it? Okay, so go ahead, pause the video, and draw those. In 5th grade, we learned how to find the area by multiplying the length times the width, right? And that would be for a square. But here we have a parallelogram. So we can't technically use, we can use the length or the width, but we can't use the length because the length has been stretched out a little bit. So we actually have to use what we call the height. How far is this line from this line? And we can't use this line to measure it because there's actually a shorter way there. Okay, so we have to call this now the height. And because we're calling this the height, now we're calling this the base. So it's like you're looking at the side of a building. You see? Height and base of a building. So we use the formula area equals base times height. And then when we do measure it, we see that our base is 6 squares. And I know that it's missing a little bit of the square there, but we actually count the bottom line. Because that little bit that we're missing there, we have it there. So we count across 1, 2, 3, 4, 5, 6. So our base is 6. In our height, we count the height. Not this line, remember, this line is skewed, it's been pushed. So we go 1, 2, 3, 4, 5, 6, 7, 8, and we replace the variable there. And we just multiply 6 times 8, and that gives us 48. So our area is 48 units squared. You can also measure the height of a parallelogram on the outside. You don't necessarily have to go on the inside, which you could. It would work just as well, or from here to here, it would work. But you could also measure it from the outside. As you can see there, we measured it at 11 centimeters. And we can replace the variable h with 11. And it would work the exact same way. So let's try A and B. We first write out the formula, area equals base times height. And then we replace the variables. Base is 1, 2, 3, 4, 5, 6, and our height is 1, 2, 3, so we replace them, and now we multiply. Whenever you have parentheses, you multiply. Remember, 6 times 3 equals 18, but don't forget to include the units. Now, we're not given units here, so we just have to simply write the word units. And it's squared because it's 2 dimensions. Now let's try B. Please copy down the formula, area equals base times height. Our base is 4 and our height is 16. So we replace the variable, and 4 times 16, as we mentioned earlier, is 64, and this is meters. So we can write our units in meters squared. Now don't forget about the units. Sometimes you'll be given the height but not the base, or the base and not the height, and sometimes you're given the area. So what do we do when we're missing one variable? Well, we know how to work this. We've been working with the equation of the line. So if we're given area and the base but not the height, we replace the variables and then we work as if we were doing the equation of the line. So remember, in the equation of the line, we want to isolate the variable that we don't have. If it's multiplication, we have to divide it out. You see how we divided it out there? So this is gone. And then whatever you do to one side of the equation, you must do to the other side of the equation. So we divide 45 divided by 9, and h is 5. Makes sense, because 9 times 5 is 45. 9 times 5 is 45. So let's do that. Okay, go ahead and copy the formula down for question C. In question C, we're given the height, right? We're being given the height, but we're not being given the base. The height, but not the base. So let's fill in the variables. Okay, so we have 48 is our area, right? 48 equals our base. We don't have, so we just write base, but we replace the variable for height. Okay, here we have multiplication. So what's the opposite? We have to do the division property of equality, and so we divide it by 6. So we can get rid of the 6, and this side also gets divided by 6. So now we only have our base left, and when we divide 48 divided by 6, we get 8, right? 8. So our base is 8. And just to be clear, the base is 8 meters. Now it's not square, boys and girls, it's not area, it's just one dimension, so we just write 8 meters. Alright, now let's try D. Please write down the formula. Area equals base times height, and now let's replace the variables. We have, we can call this the base, because it's the bottom one, and the base is being measured from one end to the other, okay, the lines. Remember, we don't measure this line. Or we can call this the height, you choose. Let's call this the base, okay, and we have our area. So I replace my area with 96, and I replace my base with 8. Now let's isolate the variable. Remember, this is the equation of the line, so in order to isolate it, we have to divide it by 8. So this 8 is gone, and I'm just left with h. And I divide the 96 divided by 8, and it's 12. And don't forget that this 12 is not yards squared. It's just 12 yards. It's only one dimension. It's just this, it's this dimension right there. Okay, so our height is 12 yards. Please leave the guided practice 9-1 for class and complete the front page of the independent practice as you see here. On the back of the page, you're being asked to draw 5 parallelograms that each have a height of 4 centimeters and a different base measurement on centimeter grid paper. So here you have the parallelogram, and you see that it has a height of 4. You have to draw 5 different ones that are not, that all have this, a separate base, a different base. They're all different sizes, but they all have the same height. Now you don't actually have to draw them. What I want you to do is just collect the information on the table and then graph it. So you see the height has been given to you for all of them. Now you can fill the base up with 1 centimeters, 2, 3, 4, 5, and then 1 times 4 is 4, 2 times 4 is 8, and so on, and you can graph them over here. Remember that this is the area and it's centimeters square. And then we're going to graph it, where the base is 1 and the height is 4, that would be our first one. The base is 2 and the height is 8, and so on. Okay, so we graph it and you can see that we have a proportional relationship. And then when we describe the graph, you're going to notice that it appears, the graph appears to form a line. And here you have it. This is the sample answer, as I was mentioning. You can change the base gradually by incrementing it by 1, and you'll see that when you multiply the base times height, that you're going to get these answers as areas squared. Okay, and then when you graph them, you also have to add in your coordinate pair, okay, or your order pair. And when you describe it, yeah, it appears to form a line, and it does. You see that? It appears to form a straight line. Please copy this. This is your key answer.